Yes, a very good morning, dear students. Today we are going to continue the next part of electrochemistry, the second part of electrochemistry, that is the batteries and fuel cells. So, mainly here, the batteries and fuel cells takes the major portion of electrochemistry. The first important so-called galvanic cell, which is invented by the two famous scientists, Luigi Galvani and Alessandro Volta. And these are the two famous scientists. Those are the two famous scientists who have, they have, invented this particular so-called galvanic cell or a battery. So, as a primary battery, and you can see it in the diagram. There is the two famous scientists and their work, how they have worked in the laboratory, and in the time of especially during the 17th century, like 1771 to 1800. And during 18th century, the first battery called voltaic pile. So this so-called voltaic pile, which is the pile of so many so-called layers of zinc and silver are connected through paste boards, and that is represented as like a so-called voltaic pile, and is a presentation of Volta, the famous Alessandro Volta, his battery to Napoleon. So that is one of the pictorial representation. And coming to the next important invention, that is called 1821, the first electric motor, and in 1835 the first battery electric vehicle, that is done by the famous scientist Michael Faraday and Sibrandus Strating. So let us have the next important invention in 1839, that is first fuel cell by Grove's gas battery. So here the famous scientist Sir William Grove, so who has invented this first fuel cell. It is with representation. And this is the mobile battery that we all know, that is lithium ion battery. Now coming to the definitions and types of the batteries. So what are batteries? Batteries are a series of electrochemical cells that are connected at constant voltage. So a battery is a series of electrochemical cells, so where they are producing the electrical energy at constant voltage. So what is the meaning of what is the difference between a cell and a battery? Means a cell is consisting of only one cathode and one anode, whereas a battery is consisting of several anodes and several cathodes. Okay, that is the difference between a cell and a battery. Now let us have the classification of these batteries. The batteries are classified into two types. Number one, primary cell or primary batteries. Number two, secondary cells and secondary batteries. Let us have the definitions of what is a primary battery and what is a secondary battery. A primary battery is a type of battery in which it is non-rechargeable and they are meant for single use, and once after all the reactants have been converted into products, so we can discard them after its usage. And these are called primary batteries, and they have limited power source. They are called limited power source, and they once the chemical reaction completes, so there is no further conversion of products into reactants, and hence a primary battery is like a single use type. And it is having some examples like so-called voltaic cell, Daniel cell, dry cell or Leclanche cell. These are the examples of primary battery. Even we can also take lithium primary cells and mercury cell. All these are the examples, along with zinc air battery, also an example of primary battery. So coming to the secondary battery, so a secondary battery is a type of battery in which the chemical reactions are rechargeable once the process of converting, or the process of the chemical reaction of conversion of reactants into products takes place. Further, the products again convert back to the reactants, and this is called discharging followed by recharging process. Therefore, a secondary battery is a voltaic cells whose electrochemical reactions can be reversed by a current of electrons running through the battery after the discharge of an electric current. So a secondary battery can be restored to nearly the same voltage after a power discharge. Now let us differentiate between a primary battery and a secondary battery. Primary cells or batteries are non-rechargeable and they are meant for single use, and they can be discarded after their usage. Whereas secondary cells or batteries are rechargeable and they are meant for multiple cycles of usage. And the second point in the primary cells is the cell reaction is not reversible. In the case of secondary cells, the cell reactions can be reversed. And in the case of primary cells, the third point is these primary cells cannot be rechargeable, whereas secondary cells can be rechargeable. And the primary cells, they are less expensive, whereas secondary cells are more expensive. And the primary cells, the fifth point is they can be used as long as the material are active in their composition, whereas the secondary cells or batteries can be used again and again by recharging the cell. The examples of primary cells or batteries is Leclanche cell, lithium primary cells, dry cells, mercury cells. We have so-called zinc air batteries. And secondary cells are with examples like lead acid cells, nickel cadmium cells, and lithium ion batteries. All these are the examples of secondary cells. Let us go for the primary cells. In the primary cells, we have various important type of examples are there. In those, so we will take one of the best example is dry cell. So in the case of dry cell, the chemical reactions are irreversible, and the anodic part in the dry cell or Leclanche cell is zinc and cathode is carbon or graphite. And here the anodic part of the chemical reaction includes the oxidation of cell reaction, where zinc undergoes the loss of electrons and get converted into zinc ions, which is represented as Zn gives rise to Zn2 plus 2E minus. And the cathodic chemical reaction is with reduction of cell reaction, where 2NH4 plus 2MnO2 plus 2E minus gives rise to Mn2O3 plus 2NH3 plus H2O. So the overall cell reaction is going to be net cell reaction 2MnO2 plus 2NH4Cl plus Zn gives rise to ZnNH3 taken twice Cl2 plus Mn2O3 plus H2O. And you can see in the picture with dry cell or Leclanche cell, there is an anode zinc in the inner case and a cathode present as like graphite rod, and after that there is a paste of MnO2, NH4Cl and carbon. And coming to the next important very important secondary battery, that is called a lead storage battery. So here the lead storage battery is a secondary battery. Here the anode is the lead and cathode is the lead dioxide, and the electrolytic solution is the dilute sulfuric acid. And the lead storage battery is a battery in which it is a series of 6 cells. So therefore each cell will produces a net amount of voltage of 2 volts. Therefore, it is a series of 6 cells. In a series of 6 cells, therefore totally 12 volts is generated by the lead storage battery. And the chemical reactions that are involved in this lead storage battery, like during discharging process and recharging process, can be studied. The first anodic part of the chemical reaction, which is the so-called anodic half cell reaction, where it undergoes the oxidation, where first lead, that is Pb, gives rise to Pb2 plus 2e minus, and the formed Pb2 plus ions, lead ions, in the next stage they will react with sulfate ions of the electrolyte, sulfuric acid. So therefore Pb2 plus SO4 2 minus gives rise to PbSO4, and the lead sulfate is deposited at the surface of the electrode, anode. And coming to the cathodic half cell reaction, where reduction process takes place, and here lead dioxide PbO2 plus 4H plus 2E minus gives rise to Pb2 plus 2H2O, and the formed Pb2 plus in the next step that reacts with the sulfate ions of the electrolyte, and therefore present in the electrolytic solution, the sulfate ions, they will react with the lead ions that are released. Therefore Pb2 plus SO4 2 minus gives rise to again PbSO4, where lead sulfate is deposited, okay, as like a precipitate. And the overall net cell reaction is going to be Pb plus PbO2 plus 4H plus 2SO4 2 minus. 2SO4 2 minus gives rise to 2PbSO4 plus 2H2O. This is the overall net cell reaction during discharging process. Whereas during recharging process, the same chemical reactions takes place in reverse direction. That is 2PbSO4 plus 2H2O gives rise to Pb plus PbO2 plus H2SO4. That is the very important charging and discharging and charging cycle. Okay, so now how the process of recharging takes place, it can be explained. So that during the charging or recharging discharging process, we have learned about discharging just now, and during recharging process it has low self discharge, and it has a 40% of self discharge in 1 year, and you see it has no memory, so it can't store any kind of information, and it cannot be stored when discharged, and we can't store them when it is discharged, and limited number of full discharges are there. So we will find full discharging only in limited numbers, and there is a problem of danger of overheating during charging. There is a problem of overheating during the process of charging. And now let us have some of the important applications. These lead storage batteries are used in automobile and construction equipment, and next one, they are used in backup systems or standby systems, and third one, they are used for engine batteries. Not only these things, we can also have some of the important applications, like they are used in the car batteries and as well as in the transformers and so kind of devices, because it will works as both electrolytic cell as well as so-called galvanic cell. It works as a galvanic cell as well as an electrolytic cell. So during its operation it will works as a galvanic cell, whereas during its discharging process it will works as an electrolytic cell. Okay, so that is a very important application. And coming to the advantage, it is low in its cost, it has a long life cycle, and it can able to withstand the mistreatments. It can perform well in high and low temperatures. That is about lead storage battery. Now we will be having a very important type of battery that is used in our mobile phones, which is called lithium ion battery, which is represented as Li plus containing plus ions containing battery. Now lithium ion batteries are the secondary batteries, and the battery consists of an anode, that is lithium, and dissolved as ions into a carbon, and the cathode material is made from lithium liberating compounds, especially the three electroactive oxide materials. Example for cathodic materials are lithium cobalt oxide, which is represented as LiCoO2, lithium manganese oxide, which is represented as LiMn2O4, and lithium nickel oxide, which is represented as LiNiO2. These are the cathode and anode parts. Coming to the principle of lithium ion battery working principle, during the charge and discharging processes, lithium ions are extracted from the interstitial space between the atomic layers within the active material of the battery, and simply the lithium ions are going to be transferred between anodic part of the material to the cathodic part of the material through lithium electrolyte. Since neither the anode nor the cathode materials essentially change, the operation is safer than that of lithium metal battery. And the chemical reaction that takes place inside the battery is during the charging and discharging operations can be explained based on the chemical reactions, like we have LiCoO2 plus C6 gives rise to Li1 minus XCOO2 plus LiXC6. This is the process of charging cycle. And during discharging cycle, we have Li1 minus XCOO2 plus LiXC6 gives rise to Lix plus Y COO2 plus Lix minus Y C6. This is a discharging process of chemical reaction, and we can see it in the diagram. The lithium ion battery, the principle where the positive end of LiCoO2 and negative end of LiC6, that is lithium carbide, and in between there is a flow of or moving of lithium ions that is taking place during charging and discharging cycle. Whereas during charging, the lithium ions are moving from the positive terminal LiCoO2 towards the negative terminal, that is LiC6, whereas during discharging process, lithium ions are moving from LiC6 negative terminal to the positive terminal LiCoO2, and this is explained based on the very important so-called charging and discharging process. And let us have some of the important advantages and disadvantages of the lithium ion batteries. The lithium ion batteries have high energy density than other rechargeable batteries. They are less weight. They produce high voltage out, about 4 volts as compared with other batteries, and they have improved safety, more resistance to over voltage, no liquid electrolyte, that means they are immune from leakage, they have fast charging and discharging rates. These are some of the important advantages, and on the other side there are few disadvantages also there. Number one, these are expensive and they are not available in standard cell types. And let us go for the applications of lithium ion batteries. The lithium ion batteries are mainly used in mobile phones as a mobile phone battery, as like they are also used in cameras and scientific calculators. They are also used in the so-called heart pacemakers, we call it as cardiac pacemakers, and some of the implantable devices in the body of living organism. and they're also used in some of the important telecommunication equipment, instruments, portable radios and TVs, pagers, etc. So they're also used in some of the important electronic devices to operate laptops, computers, and aerospace applications. Okay, these are the applications of the our lithium ion batteries, secondary batteries. Now let us move on to the third important category of batteries, are called flow batteries or fuel cells. There are very important flow batteries or fuel cells. What are these fuel cells means? The fuel cells are the cells that can convert energy of combustion of fuels like the hydrogen, methane directly to electrical energy. And here no process of oxidation that is taking place. So therefore fuels are generally usually taken as like gas or liquid with oxygen as an oxidant, and different fuels are the direct process of, in this there are the very important direct process of conversion of chemical energy into electrical energy taking place to a maximum extent of 100%. And the cell that is represented as fuel slash electrode double slash electrolyte double slash electrode double slash oxidant. And coming to the fuel cell chemical reaction, a fuel plus O2 oxygen gives rise to fuel products plus energy that is released as electricity, and they will not undergo the process of combustion. Remember, they will not undergo the process of combustion. So here there are two types of fuel cells. Number one, hydrogen oxygen fuel cell, methanol oxygen fuel cell. So coming to the limitations of the fuel cell, there are some important limitations to the fuel cell. They are large in its weight and volume, and here the hydrogen gas volume is the storage of the system requires large volume. The storage of hydrogen gas fuel requires large volume, and its cost is very high. So you compare it with you take the example called hydrogen gas. Hydrogen gas is very costly, and it is stored in specific temperature and pressure conditions, and therefore it should bring the a very important so called the cost of hydrogen gas to the cost low, and that's one of the limitation. And lack of infrastructure for distribution and marketing of hydrogen gas, and most basic fuel cells suffer from carbon dioxide leakage, and it should be prevented from the process of entering into the cell and reacting with the electrolyte. These are some of the important limitations. Let us move on to the very important first type of fuel cell, that is called hydrogen oxygen fuel cell. And this hydrogen oxygen fuel cell is a fuel cell in which the electrolyte, say for example aqueous potassium hydroxide, which is present to an extent of 25 to 30%, and this cell makes up the usage of high purity of hydrogen as a fuel and oxygen as an oxidant, and the reactions that are taking place between hydrogen oxygen to produce the water, and excess of electrons produces the electric current. And therefore the electrode reactions that are taking place in this fuel cell are, as at the surface of the anode, 2H2 plus 4OH minus gives rise to 4H2O plus 4E minus. At the surface of the cathode, O2 plus 2H2O plus 4E minus gives rise to 4OH minus, and the net cell reaction is going to be 2H2 plus O2 gives rise to 2H2O, and the product of discharged is water. Only water is obtained as the main product, the only product. So there are no byproducts, and hence it is the best source for the drinking water purposes. For the astronauts, especially those who are traveling through space vehicles called as astronauts, they drink the water by having this hydrogen oxygen fuel cell along with them. So here the standard EMF of the cell produced by this H2O2 fuel cell is 1.23 volts as a practical value, as a theoretical value, but on practical conditions we will observe there is about 0.8 volts that is obtained as the practical value. So because theoretically it will gives you 1.23 volts, on a practical analysis or study we will find there is about 0.8 volts voltage EMF that is produced. Okay, so this is related to the so-called the H2O2 fuel cell. And now coming to the applications of H2O2 fuel cell, it is mainly this is used an auxiliary source of energy in space vehicles, submarines and military vehicles. And in order to survive in space for about 11 days, we should carry 250 kilograms of the H2O2 fuel cell. Okay, next the product in this cell is only water, and therefore it is used as a valuable fresh water and the source for astronauts to drink. Okay, so now let us move on to the second important type of fuel cell, that is methanol oxygen fuel cell. So coming to the methanol oxygen fuel cell, in this cell methanol is used as a fuel and oxygen O2 is used as an oxidant to generate electric current. And this cell has two electrodes. One is the porous nickel electrode coated with platinum or palladium catalyst, which acts as an anode, and the very important second one, which is coated with a silver catalyst, acts as a cathode. The same nickel electrode which is coated with a silver catalyst which acts as a cathode. So anode is a part of the electrode where it is a porous nickel electrode coated with a platinum or palladium catalyst, and cathode is a part of the porous nickel electrode where the coating of silver catalyst takes place. And the electrolyte that is used here is KOH, potassium hydroxide, which is taken in between the two electrodes, and you can see it in the diagram. And let us have the electrode reactions that are taking place at the surface of anode and cathode. At anode, the very important chemical reaction is methanol CH3OH, which combines with OH minus ions, hydroxide ions, and gives rise to the formation of carbon dioxide and water along with the release of electrons. So that reaction is given as CH3OH plus 6OH minus gives rise to CO2 plus 5H2O plus 6E minus. And the next, at the surface of the cathode, there is a chemical reaction that is taking place between oxygen, water by gaining of electrons, and gives rise to the formation of hydroxide ions. That is given by 3/2O2 plus 3H2O plus 6E minus gives rise to 6OH minus. Okay, and the overall net cell reaction is CH3OH plus 3/2O2 gives rise to CO2 plus 2H2O, because here the 3H2O cancelled with the 5H2O and remaining only 2H2O is possibly observed. And here in this very important type of so-called methanol oxygen fuel cell, it is producing both carbon dioxide and water as the products. In this, carbon dioxide is a very important pollutant and it is a greenhouse gas, and whereas water, which is produced by this process, it is especially used for drinking water purposes. So this fuel cell is again used as a source of drinking water. And there are some advantages of this methanol oxygen fuel cell, and these cells mainly are responsibly they are stable at all environmental conditions. So especially these are stable at all conditions of environmentally, temperature and so kind of pressures and all. So it is stable at all conditions, and they are very easy to transport, and they don't require complex steam reforming operations. And methanol poses less risk to aquatic plants, animals, and even human beings than gasoline. And next we will be moving on to the advantages. So what are the important other advantages? Means the reactants and products are environmental friendly, high efficiency of energy conversion from chemical to electrical energy, and the fuels and electrolyte materials are, they are available in plenty, and they are inexhaustible. Like in the case of they are inexhaustible, their availability is abundant. So unlike in the case of fossil fuels, their availability is not too high. So fuel cells, even they are operatable to 200 degrees centigrade, and so finds applications in high temperature systems. And the next important advantage is that it is highly economical as well as safe, and it is even compact and as well as transportable. So like this, even we have fuel cells like methanol oxygen fuel cell, and so-called hydrogen oxygen fuel cells, like batteries, like primary and secondary batteries with so-called the first one galvanic cell or voltaic cell, and secondary battery lead storage battery. And we have learned about the types of so-called batteries and fuel cells in this class. Hope you all understood today's class, and we have learned about all these aspects of batteries and fuel cells in this class. And coming to the batteries, we have to study about lithium ion batteries as very important concept, and in the case of fuel cells we should study more about H2O2 fuel cell. Okay, thank you.